Ladies and gentlemen, what I want to talk to you today is about the 3 thermal conversion technologies. So please bear with me. I will now share the screen. So just one more second. And we'll be ready to go. So this just one slide. And there are 3 thermal technologies. I think we have seen these slides before, but now I want to explain in detail. The 3 thermal technologies: pyrolysis, gasification, and incineration. Here are the temperature where normally the process is done. For pyrolysis is from 450 degrees, in our case, which is low temperature conversion. And a lot of people there outside is doing pyrolysis up to 2000 degrees. A common temperature is around 1000 degrees. Gasification is the same. There is our special case, which is gasifying at a low temperature, 450, below 450 degrees. But also very well known are gasifications around 1000 degrees. And if you are work with plasma gasification, plasma is not a different technology, it's a case of gasification. So you have temperature above 3500 degrees. And then you have incineration. Incineration is always at the maximum temperature of the heating value of the material, and it is around 1200 degrees, almost fixed there by incineration. So what is the difference between these processes? I have here the primary products, no? And that is what you obtain as the primary product from this process. And this, ladies and gentlemen, is not an invention. This has been always like that since the inventions. Of course, incineration we invented for more than 10,000 years ago when men invented fire, no? But the understanding of pyrolysis and gasification has now around 200 years. And it's full of literature analyzing those processes out there. What I'm doing here is just a review. I'm taking what is solid science and put here as a demonstration. But I'm not inventing anything here. If you do pyrolysis, you always have 3 products, always 3 phases. There's no way you have something different. And the 3 phases are: you have char, which is pure carbon, 38%, it can be 40, it can be a little over that, but normally this is a good number, 38% char. And then you have up to 43% of this pyrolysis oil. What is the pyrolysis oil? When you do pyrolysis, which is an anoxic, without oxygen process, you are heating at this temperature the material in an autoclave kind of device, there will be internal breakdown of the bonds of the material you are pyrolyzing. If you are pyrolyzing whatever carbonaceous material, they will break. And of course, you know, gas, liquid, and solids. It's just a matter of how many carbons the compound has. If the compound has 1 to 4 carbon, is a gas, And if the compound has from C5 to C, whatever, 23, it is liquid. Above 23, it will become more like a wax, no? But this is what you go into this oil, is the breakdown of compound. If you have an homogeneous compound, let's say you have polystyrene, pure polystyrene, and you break, you will have, among other things, a lot of monomers of styrene. This is very important. We will break, you will have the styrene, and you have, of course, the glycol, both compounds that go there. So you could use this to repolymerization if your material is completely clean. But I see here what you can do with this procedure. You can, of course, the char can go to activation, and then you have char, biochar, activated carbon. These are interesting materials out of pyrolysis. With the pyrolysis oil, you can, of course, extract whatever substance you have there, and then you have chemicals. But I can tell you, this extraction can be very difficult, especially if your material, the EDOT, the entrance material, are not pure. You will have a lot of problem here. And then you have always a strong gas. And this gas can be used as heat for the steaming boiler. You can produce power, as I'm saying here. But one very important point, this strong gas is not syngas. This is a common mistake. I see there in the people presenting things and pretending this gas here is syngas. It's not by definition of syngas. This gas is the gas, that is why we call here strong gas, from the homologous series, C1 to C4. Syngas is something else. I've just explained. If you do gasification, as I said, this here is an anox, no oxidation, no O, so syngas cannot be formed here in pyrolysis. Gasification, on the other side, is a oxidation process, a limited oxidation. We call in chemistry under stoichiometric oxidation. You do not complete oxidize. If you complete oxidize the product, what you have is incineration. This is the complete oxidation. Here, you are doing a limited oxidation of the product, and what you obtain, 99%. 99% the conversion of your carbonaceous material to syngas. Syngas, by definition, is a gas composed of hydrogen and carbon monoxide. Pay attention, monoxide, not carbon dioxide. There is no carbon dioxide. So hydrogen, and if your material has, like plastics have, no normal the ratio of 2 hydrogen per carbon, per each carbon, then you end up with the syngas with that composition, 2 hydrogen for each carbon molecule. This is a syngas. And if you do the equipment well, if you do the process well, you can obtain a highly pure syngas here. What you can do with syngas, the simplest you can do is just separate the gas. If you separate the gas, you will have on one side hydrogen and on the other side carbon monoxide that you can change, send to the chemical synthesis. That is the separation. But as the name says, syngas, gas for synthesis, you can do chemical synthesis. And when you do chemical synthesis, all of chemistry is available for you. There is this technology, over 100 years of existence, called Fischer-Tropsch, and you can use Fischer-Tropsch over methanol to producing the whole chemistry, including new plastics, if you are deriving your product from plastics, or whatever you want. Of course, you can also produce fuels, diesel, middle distillate, aviation kerosene, and fuel gas. You can do all the process. So this is, of course, the most flexible process you can have. There is no limitation for that. And last, but you can also classify this process of material recovery and, of course, energy recovery. If you go to the next process, it is exclusive energy recovery. It is incineration. When you incinerate the material, you get a lot of CO2, you get water, vapor, and you get a lot of heat. So you convert this in 85% heat. This is very exotherm. You have a lot of heat. As you know, incineration produces lots of heat. And this heat you can, of course, couple to a boiler, and then you produce steam. And with the steam, you have power. So here you have, of course, power, and you can do power to X if you want, but you have power from incineration. So these are the 3 processes, very well explained. And if you have any questions, just ask me down. I will endeavor to respond any questions that you send me. Thank you so much.